All right, I'm going to work through problems 11 through 20. Here we are given a couple functions that model populations, f of x, and another function, g of t, models the total cost of Medicare in billions of dollars. So they want us to do two things. They want us to interpret g over f and then evaluate g over f of 10. Well, the first part of this is kind of irrelevant if I look at the answers, right? They all have the exact same description of what's going on here. So really all we need to do is focus on finding g over f of 10. All that's asking us to do is to plug in 10 to both functions and take the results of g and divide it by f. When I use my calculator to do that, I got 13.16, making C the best answer. And we are done. Moving on to number 12. We are trying to find the domain of this function. So there's a couple things that can go wrong. The denominator should not equal 0, and the square root must be not negative inside. So as I look at this, I know that x minus 10 must be greater than 0. Because if it were equal to 0, the denominator equals 0, and I'm in trouble. So I'm going to solve this inequality. X is greater than 10. So I look through my solution sets here, and see my solution options. I can see that option D is the best one because that excludes 10 as a specific answer. On number 13, they ask us, does the graph represent a function that has an inverse function? That's where we use our horizontal line test. I can see that horizontal line crosses the function in more than one spot, meaning that the inverse is not a function. While we're on the topic of inverses, we see number 14 asks us which two functions are inverses of one another. Which two functions undo one another? Well, my three functions are x times 5, x divided by 5, and 5 divided by x. We know that multiplication and division undo one another. So f of x and g of x are inverses. On number 15, we want to graph the function and its inverse and identify the domain and range of each function. Here I have a cubic function shifted left 3 units. So I should have the point -3, 0 on my graph. I can see that A does not. A is not a good answer. I am looking at C. It does not have the appropriate graph of x cubed shifted left 3 units. But options B and D do. So I know that if I have the point -3, 0 on my function, the point 0, -3 would be on the inverse. And let's see which of these graphs meet that criteria. Well, I can see here that I have a positive value on my inverse, meaning D must be my answer. Just to verify, I'm looking at my domain and ranges. I can see that in all 4 solutions, domain and range are all the same. So we can't really use that to differentiate. We must use the graphs. Moving on to number 16. They're again asking us which two functions are inverses. I have x being the square root of x. I have 1 over the square root of x and x squared. Well, looking at these two functions, I know that a square root undoes a square, which means that f and h are inverses. On to 17, we are asked to find the distance between 2 points, and maybe you're thinking distance formula, which we know is just another form of Pythagorean theorem, but pay attention, save yourself some time. Our y coordinates are the same. So the straight line distance is just between 0 and 4 in the x direction, meaning A is our first answer. Excuse me, is the best answer. On something like 18, that's a little bit different. My distance formula, I'm going to plug in and simplify. I know it's going to be the change in x squared, so 6 to -4, plus the change in y squared. I go from 5 to -6, so that's going to be 11 squared. So the distance here is going to be the square root of, 221, which I believe is one of our answers. We can see there D is the best answer. Here we are looking for the standard form equation of a circle. We know that the standard form looks like this: x minus h squared plus y minus k squared equals r squared. So if the center of my circle is at 0, 0, I know for sure that I'm going to have x squared plus y squared. Now the real question here is dealing with this radius of root 6. What we do in the equation is that we square that quantity. So square root of 6 squared would be 6, meaning C is the best answer. And finally, on number 20, we have another distance problem. Again, our distance is going to be the square root of the change in x, which is 6 quantity squared, plus the change in y, which is 8 quantity squared. Our distance here will be the square root of 36 plus 64, which is 100. That distance will be 10. And I can see that option C is the best one to choose.